So mass spectrometry, basically you have some molecules that are in some solution that you have. You will ionize them and then you can separate them based on their weight or more specifically based on the ratio of their mass to their charge. This allows you to separate complicated mixtures where you have many different things in a solution. You can separate them and look at what is in your solution. So mass spectrometry is very relevant and something that we've all come across in our everyday life. So one reason why it's relevant is in airports, for example, when you are being drug tested, you had a sample taken to see if you're carrying drugs. This goes to a mass spectrometer where they will try to measure they'll try to compare the mass that they detect from your sample to see if you've got any drugs in your luggage. So the other thing that's good for this is for looking at biomolecules. You can think, for example, that your blood is a very complicated mixture of many different proteins. There's fats in there, there's sugars, there's so many things. With mass spectrometry, because we're separating things based on how much they weigh, we're able to take this complicated mixture, spread it all out and look at what is there and even isolate different components to study their structure, their characteristics, what they are built of, for example. So MS Vision specializes in native mass spectrometry. So it's quite easy to study any old protein or molecule and get that mass spectrum of this, but that's not always very relevant. If you think about the difference between having a protein flying through the gas phase compared to a protein sat in your cell, there's no water, there's no other surrounding proteins. So what we need to do is try to preserve as much of their surroundings as possible for as long as possible. So we are experts in making sure that we can take our proteins, keep them looking in the same shape, having the same molecules bound to them as you would have had in solution, and being able to study them. And we do this by having modifications to mass spectrometers. So for example, increasing the mass range of our quadrupoles so we can fly larger masses through them, because of course you do not want to have hundreds of charges on a very small protein because they will repel and it will no longer be having the same shape. But if you have less charges, you have a bigger mass to charge ratio, so you need a bigger quadrupole so you can have higher things flying through. You can study their composition, you can study their shape. And this is something that is very difficult in solution with current existing techniques. And it's a big strength of mass spectrometry that we can then take these things and learn something new and gain knowledge that we cannot gain by looking at them in solution.